Remember we mentioned before that we can actually get a regression line, whatever our data looks like. So even for this data set, the software will give us a line. And the question is, can we use that line for prediction or not? And you could see that if we get a equation of the line here and we use it, it's not going to help us predict what the next data value is going to be. But in case of this one on the right, if we get a model, a line equation for this data set, it will help us predict the data values with a certain accuracy. So the question is, when can we use our line, which the software gives us, and when can we not use it? So we're gonna answer this question in this video. So here's the thing. If the linear correlation coefficient shows a weak linear correlation between variables x and y, then the best predicted value for any x is the average y value, which is denoted by y with a bar. Above it is just y with a bar. Okay, so if the linear correlation is strong, then we use the given equation. If the linear correlation is weak, then we just use the average y value. Just remember that the weak correlation is the correlation closer to 0, and the strong correlation is the one that's closer to either -1 or 1. So let's take a look at these examples. It says, for the following models, find the best predicted value. Find the best predicted value of y for x equals 4, given the correlation coefficient 0.941. The average y value is 7, and the number of values used here, number of paired data values is 36. And the equation of the regression line that they got was 8 plus 4x. So now our question is, can we use the line or not? So now here, because the correlation coefficient of 0.941 is close to 1, we're going to use the line. It reflects a strong correlation. That means that we may use the line to find the predicted value. So we're going to use the equation to set x equals 4, plug it in, and our predicted value is going to be y equals 8 plus 4 times 4. So that's 8 plus 16. That will give us 24. Okay, so our best predicted value is 24 in this case. Okay, let's take a look at question B. It says, find the best predicted value for y when x equals -1, given that r is 0.22. And the average value for y is 6. There was 24 data points used in establishing this line. So the software spit out this equation for the line, but notice that the correlation coefficient is 0.22. So the question is it closer to 0 or is it closer to 1? And of course, I think that you realize that this is closer to 0 than to the 1. So we're going to say because R is very close to 0, the regression line does not represent our data. And therefore, it's useless for prediction. And here you go. So if this is the case, what is our best predicted value if we cannot use the line? Well, in this case, we're going to use our average Y value right here. So our average best prediction is Y equals 6 for any X value, right? So they gave us X equals -1. We're going to say the best predicted value is 6. If X equals 2, the best predicted value is still 6. If X equals 10, the best predicted value is still 6. We don't put it in to the line. If you're not given the line and the Y value or the average Y value, how do you do that? Well, you look at all of your Y values and you average them up. So for example, if you're given this data set to find the average Y value, you would add 1, 7, 2, 5, and 5 and divide it by the total of number of Y values. Divide by 5. That's how you find the average Y value.